just welcome you
Okay.
on stage and thank you for coming. So
Yeah,
I
thank you.
will. Kevin is gonna works as a developer advocate at Traefik Labs, and today his talk is about service mesh, and it doesn't need to be messy, so it doesn't need to be complicated. And in order to keep it simple, we can use mesh. That is I don't know if I pronounced it correctly, but I'm sure you will do it better than me. So I will leave the stage for you. Your slides are shared. So thank you for coming and good luck.
Great. Well, thank you, everyone. And also, I just want to thank you all for joining the session and hanging out with me today. Also want to give a shout out to Gianluca for inviting me and all the organizers of CloudConf for putting this together. So today I'm going to be talking to you about why service meshes don't have to be messy and how we're keeping things simple with Traefik Mesh. And we actually changed the name of the product from Mesh, like an M-A-E-S-H, to Traefik Mesh, just so that we're clear what we're talking about here. Now, Traefik Mesh is a service mesh implementation created by the developers, the same developers who brought Traefik, which is, you're probably familiar with it if you've been using containers and cloud native stuff for a while. So just to share a little bit about myself before we get started, my name is Kevin and I do work for Traefik Labs. They are the creators and maintainers of Traefik, Traefik Mesh, and Yegi. And I'm also an organizer of Cloud Native Nashville and DevOps Days Nashville. I've been a Docker captain for a few years now as well. I've spoken on topics such as observability, DevOps, and software development a number of times over the past few years. And just some hobbies, some side notes, things I like to do. I'm an avid cyclist. Like I think it's been a great year for cycling. I've gotten like over almost 5,000 miles this year. Rock climber. I enjoy occasional impromptu hikes every now and again. I'm also involved here locally with a company, and I'm an SRE consultant for Single Music, and that's a digital music and live stream provider based in Nashville that was started in 2016. You can learn more about Single Music and our journey with Cloud Native on the Cloud Native or the CNCF blog. I wrote a blog post about switching from Docker Swarm to Kubernetes that was posted this past summer. So I'm actually interested in hearing about which service mesh you're using. So you can go to the URL here at the top of the slide. You can, if you would please submit to this anonymous poll if you have a chance, and I'll come back to this at the end during Q&A, and we'll have something to talk about if there are no questions. Now, before I jump into explaining what a service mesh is, I'd like to take a moment to talk a little bit about kubeproxy and kubedns, because that's what most people are familiar with and they're using for service-to-service communication in Kubernetes. And it's really a logical extension point for a lighter weight service mesh. And I'm going to talk a little bit more about that later. But essentially, kubeproxy provides basic load balancing across a pool of IPs using IP tables. And this ensures that service-to-service communication will work once a service is resolved by the internal DNS handler, which is kubedns. This is a round-robin load balancer, and for reasons of simplicity, it's not very configurable. Okay, awesome. I'm getting responses on the poll. Feel free to fill that out throughout the talk, and I'll come back to that at the end. So service meshes exist to either extend or in many cases outright replace kubeproxy and kubedns. And this is because service mesh introduces a whole slew of additional features to your Kubernetes cluster. And those resources are typically managed through the Kubernetes API and through custom resource definitions or YAML. And in the next slide, I'll talk about some of the benefits of the features that are exposed by service mesh. And those things include features such as traffic management, security, and observability. So what are some of the benefits of using a service mesh? Why would you put this in your cluster? I noticed several of you already use a service mesh, so you probably know the answer to this, but I'll cover it here anyways. It's a logical point to abstract away a bunch of functionality that traditionally before we had Kubernetes, this stuff was all handled within applications or in hardware. So service mesh will add functionality to service-to-service or east-west communication, such as advanced routing, and that includes traffic management capabilities like traffic splitting with weights. In other words, I want to send more traffic to one service versus another, and these could be different versions of a service. The ability to incorporate access control policies, which limit which services can access specific endpoints or routes on another service. It can handle the enforcement of and processing of mutual TLS encryption and authentication of service between service communications. Also, we can do some more advanced traffic management, such as retrying, backing off, and circuit breakers with our service-to-service communication. So what this ended up doing is it allows operators of applications that run in the mesh to manage those capabilities at a provider layer rather than at the application layer. Because it's been identified that it's really difficult to maintain all these different concerns across a bunch of different applications if you have a bunch of polyglot services and you're distributed across a large organization. It just centralizes those features. So finally, a service mesh allows for a centralized emitter of metrics and traces that represent the above behaviors, which is helpful for creating automation around alerting performance and scaling events. So some of the challenges we wanted to overcome when we created a new service mesh implementation is that we had heard from the community that the implementation of service meshes were difficult to configure and manage. We wanted to present an easier way to install and implement many of the benefits of having a service mesh without having a ton of upfront work to get it running. They've been criticized for imposing significant resource overheads, so we wanted to build something that didn't impose nearly as high of a CPU and memory requirement to run a service mesh. We wanted the solution to be minimally invasive and ideally be traded out with another solution without a significant amount of effort. And with that, we also wanted to offer flexibility with how they use their network, like whether, let's say they wanted to opt out of using a service mesh, it shouldn't be difficult to work around having a service mesh in your environment. And to that point, opting into a service mesh shouldn't be a all or nothing proposition. We wanted to go into the route of you should be able to opt in rather than opt out. It should just be rather, I want to use a service mesh, so talk to this DNS host name instead of the normal Kubernetes one that kubedns provides. So when we set about solving those challenges, it wasn't really clear how we were going to achieve that. But what we ended up discovering is that we already had a lot of the tools we needed with Traefik in order to implement a service mesh, and this is some of the thought process that went through the design of Traefik Mesh. Because what we realized is service mesh is just another proxy, or rather a collection of proxies, but slimmed down with features that only target service mesh use cases. And some of the reasons we wanted to use Traefik is that it was actively maintained, it was considered secure, and it had many of the features we already needed. And the development for mesh or Traefik Mesh would enhance traffic and vice versa. So the work that we did incorporating mesh features into Traefik would improve traffic overall, and vice versa. So some of the reasons we didn't want to use Traefik, though, as a sidecar, which is how most service meshes go about implementing their proxies, is that throwing a full-size proxy into a sidecar on every single pod in your environment would have metaphorically resulted in the traffic gopher being run over by a car. It just would have been way too much overhead. So we discussed forking it and creating a lighter weight proxy and still using the sidecar approach while adapting some existing middleware for service mesh. That was under serious consideration at the beginning. But the situation we wanted to avoid was everybody gets a sidecar proxy, because that has its own problems. And some of you are probably familiar with Istio and many of the other service meshes, that a proxy gets installed on every single pod. And that does have advantages, as you're able to manage every aspect of traffic entering and leaving the pod. But the disadvantage is that you create a lot of overhead with this, as you have a pod installed on literally every proxy in your cluster. Those rules have to be propagated, so it creates a lot of network I/O. And also, when you want to upgrade your proxy sidecars, you're forced to make the accompanying service unavailable. So it doesn't make upgrades very friendly. Now with Traefik Mesh, what we ended up doing is we didn't need the sidecar approach for service-to-service communication. We were able to achieve it by using a feature of core DNS called domain stubbing. And you can learn more about that on the link here. And just real quick, I am going to share this at the end of the presentation, the slide deck. So you can come back and click on all the links if you like. So the Traefik Mesh controller modifies the existing kubedns controller by introducing a new domain name that routes traffic through a custom proxy that is deployed by the Traefik Mesh controller. So what we're doing here is we're leveraging the already existing DNS provider in Kubernetes and installing a single proxy per node and a controller which handles collecting the configuration from Kube API and disseminating that information to each one of the proxies on those nodes, which were deployed as a DaemonSet. So one of the really big benefit to this is that Kube proxy still functions and Kube DNS still functions as normal. So pod-to-pod communication, as we're traditionally familiar with it, still works. And it's pretty great considering you might need some sort of communication that needs to be really fast, or you just don't want that sidecar proxy in there, or you don't want to go through the mesh. You can still use that while having the mesh to opt into, and it becomes really easy to work around. So ultimately, Traefik Mesh ends up using traffic deployed as a DaemonSet, custom implementation of it, because we found a reasonable way to avoid every pod gets a sidecar approach. And the DaemonSet proxy approach keeps the routing in the software rather than doing any kind of IP table shenanigans, and that has its own performance trade-off, but it also makes it really easy to implement and work with. So as a result, the opt-in behavior becomes as easy as a new domain name record, making that optional and transparent. And in addition to that, we utilize the SMI spec. So if you're familiar with that, you're able to easily configure the communication within the service mesh using that specification. And I'm going to go through that with the demo that's coming up here in a moment. So how did we end up incorporating all these features in a vendor agnostic fashion? As I mentioned, we used the SMI spec. And if I had more time, I would go over several use cases for SMI, but for the sake of keeping it brief, because I only have like 10 more minutes and getting right to the demo, I'm going to explain one example that covers canary testing with a service mesh. So in this example, I'm configuring an HTTP route group against a cookie and a user agent. And this becomes pretty powerful when the operator wants to route traffic based on, say, a specific user or technology or metadata for use cases such as A/B testing or canary testing. So let's consider the configuration we're looking at here. I'm targeting Android users based on their user agent, and I'm looking for a cookie that indicates the user is an insider. Perhaps they've opted into testing for us. And in the next example, I'll show you how this can be utilized with service-to-service mesh communication. So using the SMI traffic split, I can do weighted routes, and by extension, this is just canary testing, by applying that HTTP route group that I just showed you in order to target users who are using Android and who have opted into the test. So here, it's just simply saying anybody who falls into that route group category, this traffic split applies to them. So instead of routing to the Android test or to the website service, I'm going to route some of them to website v1, and then, well, most of them to website v1, and then only a small portion to website v2. You can see a lot more examples of SMI in their GitHub repo covering the spec, but for now, I'm going to show you an example of a canary test and how traffic mesh works alongside routing in a Kubernetes cluster. So the demo I'm about to show you, what I'm going to demonstrate is the canary test of non-ingressed or service mesh east-west traffic. I'm going to demonstrate using standard routing alongside mesh routing, and I'm going to show you all of this using Jaeger, as it makes it a lot easier to actually visualize where all this traffic is going and how it's working. So before we get into that, let's check out the application that I have running. This is Spring Pet Clinic demo, and it's a simple CRUD application where you can edit owners, add pets to owners, add visits to their account, as well as maintain a list of veterinarians. It's just a really simple CRUD app, but it's set up and split up into multiple services, and it has internal service-to-service communication as well as ingress communication. So it's a pretty good example for what I want to show you here. So the first thing I notice here is this is actually broken. I'm not getting information in my service. And if I look at this particular request, it came back with a 500. And if I look at the response, we can see that it's an internal server error, and it's trying to communicate internally in my cluster and talking to customer service local.traffic.mesh. And I configured this service specifically for that because I wanted to communicate with the mesh service. So, well, why is it broken? Well, I haven't deployed traffic mesh yet, which I'll do right now. And while I do that, I'm going to show you what is happening in the cluster and how and what's going on while that deploy is happening. So as I mentioned, it's really easy to install traffic mesh. I'm not deploying a trace agent because I already have Jaeger deployed, and it's just going to use that instead. But it's just simple Helm install. So once I run this, I should be able to see here just a moment the traffic mesh controller and proxies coming into play. And it's actually rolling over core DNS right now because it's doing those patch stub implementation. And so once this finishes up, I should be able to refresh that page, and it should work. So it looks like it is up and going. And if I refresh my page here, yeah, everything's working now. So huzzah, we have routing in our service. And if I load this up and take a look at customer service and find my traces, I can see that request I just made. No, I can't, because that is a health check. All right, we can see that one I made earlier in the browser and how it came back with an error. And if we look at the log, see the admin server unknown. But we can see this one here come through, talk to the service, and query to all of the owners. And if I look into owner service, I should also see those errors coming in for the traffic mesh not working. All right, so now what I want to do is I want to show you that canary test now that we have the mesh deployed. But to do that, I need to start throwing a lot of traffic at my service, because if you're going to do a canary, you need a lot of traffic. So this will start actually pushing a lot of requests to the service. And if we look at customer service, we see a whole bunch of requests starting to come in here to our application. So, all right, now that that is deployed, let me show you the traffic split that I'm going to be deploying now. We have a customer service, and now I want to deploy the traffic split that will take 75% of the traffic that is internally being routed to customer service, go to V1, and then 25% to V2. And V2 actually has a random error generator installed into it, so it should fail every once in a while. So now I need to deploy and I also need to actually deploy those V1 and V2 of the service. All right, now that V1 and V2 of my service is deployed, I should see them here in just a moment. Here's V1, and some requests have started coming into the application. So internal requests are now flowing to version 1 of the service, and V2 should show up here in just a moment. And we can see here that in addition to that, we have requests coming into V2. And we can look for ones that have errors. And we can see within this request, I have a force failure where my request is denied because I'm inducing an actual failure into it purposely. All right, so in addition to that, the last thing I wanted to show you before we wrap up is how the system is still routing traffic to both services that aren't using the service mesh and then traffic that to services that are using the service mesh. I think we may have there it is. All right, so we have a request coming into my ingress controller, which is traffic, and then the service eventually picks it up here at get owner details. This makes two requests. It makes one request to customer service, and then it makes another request to my visit service. And we can see here the request coming into the traffic mesh for the customer service, which we told this service to use the mesh route. But in this service, I'm making a request just the visit service, and this is using direct-to-direct communication. So it doesn't go through any sort of proxy. It just goes directly to the actual service, the hostname visit service. So this is still going through kube proxy and kube DNS. So there we have the demonstration for you. I hope you can see how that worked. All right, so now let's go back to the presentation and let's wrap up. So in summary, traffic mesh, we wanted to provide a novel approach to service mesh while keeping the implementation lightweight and flexible. And we're really excited to see what the future holds for the project. We've been involved with the SMI community and we've implemented new capabilities to the spec, including support for UDP, and we're going to continue to be involved. And we're working on implementing and planning for additional enhancements, things like support for metrics and the new features being introduced to the SMI spec, as well as mutual TLS encryption. So we are hiring. Feel free to check out our careers page. If we have also multiple ways for you to get involved with the community, we're always looking for active maintainers and contributors to the code, as well as moderators for our forums, our projects, as well as our ambassador program. We'll also be hosting a webinar with one of our principal developers doing a deep dive into Traefik, the code base, in December. So keep an eye out for it on our Twitter account and sign up for our newsletter on traefik.io if you want to hear about that. So thank you all for taking the time to watch the talk. If you have any questions, you can reach me directly via Twitter or LinkedIn at Not Sure If Kevin. And I look forward to hearing from you. So let us go to questions if we can.
Yeah, thank you for your presentation. Looking at the chat, I don't see any direct question to you, but you left like asynchronous channels that people can use to reach out. But now I'm curious to know more about the result of the form. So
yeah, I mean, I was kind of surprised. Like, so Traefik Mesh, one of the things I don't know if I can see is like how many people responded to it. So, I mean, that's surprising. We weren't really aware of users using Traefik Mesh in production. So if you are, please reach out to me. We want to talk to you and learn about how you're using it. And we want to get your feedback because that's how we improve the project. I mean, also the no plans for a service mesh. I've always been interested in hearing why people aren't planning on using the service mesh. Like, why don't you want to? So again, I'd be really interested in hearing feedback from you all who filled out this form, like some of the rationale behind the answers you gave. But it looks like nobody's really piping in, so maybe we'll just wrap up. I don't know. You have any questions, Gianluca?
I mean, I didn't try the mesh solution from Traefik yet, but I know very well Traefik has a reverse proxy. So the other, like the first open source project you delivered, and it's a very good one. So I presume if the service mesh one has the proxy, it would be very easy to use compared with maybe other solution that I used in the past. Like I used Istio, but it definitely require like a lot of learning and like testing to get to a good point. So definitely having something easier to pick up, it's a good way to start, I presume.
Cool. All right. Well, thanks again for having me.
Thank you for coming. We have a roundtable. Like we just go over a couple of questions with all the speakers of this afternoon. Do you want to stay with us?
Yeah, absolutely. I'll hang out.
It's gonna be fun. So I have a couple of speakers waiting. So Antonio should be. I don't see him. Let's start from Giuseppe. That I know he's ready, and Gianmarco is also here. So first of all, I want to thank you all the attendees for staying with us all day. It was a long journey, so I had some tea as well because it was long afternoon. So I have a couple of questions for you, for you all speakers. So let me get to them and see what we can do. So first, how many coffee per day do you have usually, Kevin?
I mean, I don't necessarily. I drink espresso for the most part, and usually it's between 4 to 6 shots. Now, sometimes, like I'll have that and I'll mix it with like steamed milk or something, but no more than 6 shots of espresso a day. Like that's my limit.
We are Italian, all Italian, so we can say that it's already a good amount of espresso. So that's good enough.
Yes.
So Giuseppe, how many of them?
3, only 3, because I want to stop now. Because 2 or 3 years ago, I usually take 4 or 5 coffee per day, and my stomach go away. go in pain. So I drink only 3 coffee per day. I try to survive.
That's
And
more than enough, I presume.
water.
Gianmarco, how many for you?
I stabilized to around 3 per day. 1 espresso after lunch and 2 Americans, 1 in the morning and 1 in the afternoon.
That's a good one. So I have to say that since I stopped going to the office like 5 years ago, I drink way less coffee than what I used to do. For me, it was probably a way to socialize and let's go and get a coffee and take a break. But now that I'm by myself, I don't need a break anymore. Almost. I mean, I can take a break for myself, so that's hard to do. Second question is, before COVID-19, did you prefer smart, remote, or on-site work? So what did you prefer, Kevin, before COVID-19?
Well, I've been a developer advocate for like 4 years now, so I'm really used to remote work and traveling a lot. So definitely prefer remote work. I haven't heard of smart working. Can you explain what the idea behind that is?
Yeah, I think for us in Italy, we had a big discussion about like the fact that even if we now can only work in remote, there are still people that are tied to 9 to like 5 p.m. in the morning, and they have to be like in some way monitored and tracked. So that looks a lot like remote work, but not really smart, because like the smartness comes from having the possibility to manage your time, and so that's maybe.
Yeah, I was going to say, I think that really has to boil down to the role, because I mean, there's some of us who are on call, and that's our block of window we work, and that's what it is. But I agree that most people, they should be able to manage their own working hours, and as long as you get your stuff done and you're responsive, like why shouldn't you be able to work those hours? But yeah.
Yeah, I definitely agree. For us, at least in Italy, there is still a big cultural shift that we have to do. So Giuseppe, I don't know if you are in office now, because your work looks good. But did you enjoy your like remote work when you were able to do it, or do you prefer like smart working?
Before COVID, I preferred to the smart working, clearly the smart working. Now, after about one.
Oh, Giuseppe, just wait. I have a question about after. So the question will come later. So now I just want to know what you prefer before.
Okay. Now, I before I prefer smart working.
Okay.
Before smart working, clearly.
What about you, Gianmarco? Before?
I've been doing freelance work for like 10 years now, and I've always done remote work. Some clients I've never met in person, and so that was my preference, even though I always prefer to do training and teaching in person. And some clients, I go to their offices. So a little bit of smart and remote, depending on the client.
So, and now after this like COVID-19, KV, after is not really after, but let's say, did you still prefer remote, smart, or you change your mind? Do you want to come back to an office?
There's some days where I've definitely missed the office. I mean, and this just comes from my role as a more of a direct contributor to product development and design. I think there's a certain amount of collaboration and magic that happens when you get a bunch of people together who work together closely. But for the most part, no, I really would. I like the freedom and flexibility being remote gives me better.
So Giuseppe, how are you gonna get back and ask for remote work now?
Now I prefer smart working also now, but I have a child. I have a child in my house, so I sometimes I need to go in office. I need to go to the office to try to concentrate, to try to socialize also with my friends, with my colleagues. I prefer smart working, but sometimes I need to go on site.
So Gianmarco, now that you can't leave your house, probably, do you still prefer remote work?
So I definitely agree with Kevin here. It's nice to be able to manage your own hours and your own work, but sometimes the proximity to other people is something that cannot be replaced with Skype calls or Zoom calls or whatever. So, I mean, I have come to appreciate the possibility of having an office and going to an office, even though I still prefer remote working.
Beer, wine, or Coke, Kevin?
I don't drink alcohol, and I don't drink sugary drinks, so I'm gonna go with water.
That's a good one.
That's the healthy one.
Beer, definitely beer.
Gianmarco?
Yes, beer.
So during the keynote, we got like 4 wines. So now we are more spread. Beers is coming. So the favorite programming language, Kevin?
Oh, I mean, I'd have to say Go, like for sure, by far.
I signed a contract. I have to say Go. Giuseppe?
Java for me is Java.
How about second favorite?
Okay, let's go with the second one.
I mean, Java's my second favorite, but yeah.
Okay.
Yeah.
Gianmarco?
Okay, I'm going to go against most people here, and I'm going to say C++. Even though I have barely any occasion of working with it, I still use it for my personal projects and in my spare time.
And now, please be polite. Your favorite, your actual IDE, not your favorite one, the one you use all day.
Bash. Just kidding. Go is what I use for the most part.
And has an IDE.
Oh no, sorry, IDE. Oh no,
Yeah.
IDE. Y'all saw it. It was VS Code. That's what I used to use JetBrains, but now I use VS Code.
For me, IntelliJ, yes, IntelliJ.
For me, it's VS Code. It's been for some time now.
I use Vim, and I can change it. I don't know how to use the mouse anymore. So, which is your favorite topic, if you have to pick one? I mean, you have to pick one because I'm asking. Serverless, containers, and IoT.
Containers.
For me, IoT.
I'll go with containers as well.
I don't know if all of you had previous experience. I know for sure for Kevin, but do you miss the real stage at IT events?
Hard yes, like for sure.
Yeah. I really miss the real stage. I really miss.
Yes, a lot actually. I wanted to take a selfie with the audience behind me, but I couldn't today because I don't know what the audience is.
Yeah, I agree. It's very hard. So which moment of the conference do you prefer? Getting on stage, getting off stage, talking to the participant, or the lunch? Which time is the best one for you?
I would have to say that, I mean, it's a toss-up between two. Getting off the stage because it's a huge adrenaline rush. And I know y'all know what I'm talking about, but also talking to the participants is a big one. So it's hard to pick between those two.
Depend on the lunch. If we have a good lunch, probably lunch is the best moment. But talking to the participants is also is important. Is my favorite.
Yeah, talking with the participants is my favorite of the three. But I also say that there are usually dinners the day before the conference, and that is also one of my favorite moments, the dinner before the conference.
That's a good one. So your favorite food or snacks when you are at the computer keyboard?
Anything that doesn't get in my mechanical keyboard, I'm a fan of. There's not much, but yeah, that's about it.
Chips, the Pringles one. Chips.
That's the one.
Water. I drink like 5 liters a day. Maybe not 5,
Oh,
but
wow.
4.
That's a huge commitment. Well done.
Yes, it is.
So, laptop or desktop? Are you a desktop person or a laptop one?
It's funny because I love my desktop and I've really enjoyed working on it while during this whole COVID thing. I'm on a desktop right now, but I don't know. You just can't beat having like 16 cores and 64 gigs of RAM when you're trying to spin up Kubernetes. So, but when you're traveling, I mean, you don't have a choice. So yeah, I prefer desktop though.
Yeah, me too. Me too. I prefer desktop too. Every time my friends that ask to me which is the best laptop to buy, I always say buy a desktop. It's better.
Mm-hmm.
Yeah, so I've actually spent a lot of money on my workstation, so I'm going to go with the desktop as well. Even though I only have a webcam on my laptop, so I use my laptop for calls, and when, of course, I am around for one client or another.
So, which technology or pattern will you be dealing with in the near future? So, what's coming next for you?
I would say it's probably going to be Kubernetes and a lot of ingress, but that's just because of the role I'm in and what I'm going to be working on. I don't know. I have a love-hate relationship with serverless. I think it's a really cool technology. I just don't see it being widely adopted. Not as much as people would probably like. But that would be one I'd be really interested in working in. It just does. It seems so niche that what can you do?
Yeah, I think serverless. I think that serverless would be. Yeah.
For me, it's going to be Flutter. Even though I am not a big fan, I'm going to have to work with it, so I'm going to work with it.
So now the last 3 questions, and you have to answer them with one single word. So say something about serverless.
I already said it. It was a niche is my word.
Future is my word.
Can you bleep?
So I'm gonna skip to the next one. So just one word about micro frontends. I don't know what to say about micro frontends, so that's on you.
What? Yeah, that's my one word.
I think the same word, white. Yeah.
I'm going to go with why.
Yeah, I mean, we are all like Java, Go, C++. Nothing about micro frontend can really come out from us,
Right.
I'm sure. So last one. One word about the CloudConf. Be nice.
I just got here. Thanks. That's my one word. Thank you.
See you live next year.
With no space altogether.
It's something I look forward to every year, so it's going to be favorite.
That's great. So thank you, everyone. We just got to an end on time, like all day. So this virtual event was very good because we didn't have any delay. So thank you for staying with us. And I'm sure you will get all the slides and all the material to your inbox at some point from the conference organizer. I'm Gianluca, your MC, and it's all for today. So thank you for coming. Bye-bye.
Bye-bye.
Bye.
Bye-bye.